Hey guys, welcome back. So we are going to start lesson 6.3. It's a 2-day lesson. Today we'll do day 1. Let me present my screen. Okay. So today we're going to start talking about logarithms and logarithmic functions. It is a new function that you've never studied before. Our goal today is to talk about changing forms and to evaluate. So first off, if I asked you to find 2 to the x equals 6, like 2 to the what equals 6? Okay, well, hopefully you're like, I'm not sure, right? Because if I was to ask you 2 to the what equals 4, right? That's a fact that we know off the top of our head. We know 2 squared equals 4. Or if I said 2 to the what equals 8, that's a fact that we know. 2 to the third equals 8. But if I say 2 to the what equals 6, well, it's not a fact that we know. And I'm not really sure how to solve that because we haven't solved equations where the variable is up in the exponent. So we need logarithms to do that. Okay. Now, we have expo form, exponential form, and logarithmic form. Those are equivalent to one another. Let me just get my pen. All right. So these two forms, these are equivalent. And that's important to know because we can change from one form to the other, right? And still have an equivalent equation or an equivalent expression, but have a new way of writing it, which might help us solve. Okay. So for exponent form, it's base raised to an exponent equals the answer. All right. So it's b to the e equals a. Base to the exponent equals the answer. Now, 2 quick things. The b value is greater than 0 and b cannot equal 1. All right. Now, in log form, now remember, logarithmic form is an equivalent way of writing expo, right? So it's log base b of a equals e. So you can think of that as log base of answer equals exponent. I'm going to have to abbreviate because I ran out of room. Okay. So keep in mind that when we're working in log form, the answer is actually the exponent of expo form. Okay. So I'll say that again. The answer to a logarithmic equation, okay, your result is the exponent of your expo form. All right. Now let me erase some of that. For log base b of a equals z, you're going to hear me say the phrase bacon and eggs. All right. It's kind of a mnemonic device to remind us how to set up a log problem. I'm going to say log bacon and eggs. Okay. So I'll say that again. Log bacon and eggs. So you know the order in which to write the letters. All right. And I think that's all I needed to say about all that. Okay, so what we're going to practice today is first just rewriting from expo form into log form and log form into expo form. Okay, so the first one says rewrite in expo form. So in other words, we want to go from log bacon and eggs. That's what we're given. And we want to rewrite that as base raised to an exponent equals the answer. All right, so what I often have students do is I have them point. That's the bacon and eggs, right? Bacon and eggs. And if I want to be in base raised to an exponent equals an answer, I'm going to write it as 6 raised to the third equals 216. All right, and we can double check that, right? If you want to grab your calculator, 6 to the third. Oh, hold on. Quit. So 6 to the third equals 216. Okay, so what we just learned, our very first problem that we've worked through, is that 6 raised to the third equals 216, which we know. And an equivalent way of writing that is log base 6 of 216 equals 3. Okay, they are equivalent to each other. All right, so the next one, bacon and eggs. So base raised to an exponent equals an answer. That would be 7 raised to the 0 equals 1, which is true. We know 7 raised or any number raised to 0 is equal to 1. Okay. Bacon and eggs, and we want to be in base raised to an exponent equals an answer form. That's exponential form. So we would write 21 raised to the first equals 21, which we know is true. And the last one, bacon and eggs, but I want to be in base raised to an exponent equals an answer form because that's exponential form. So it's 1/5 raised to the -1 equals 5, which is true. All right. So that is rewriting from log form to expo form. Now we're going to do the opposite. Let me scroll down. So now I want to go from exponential form, so expo form, which is base raised to an exponent equals an answer, and I want to rewrite it in log form, which log form is log bacon and eggs. All right. So just identify it like we did for the last problems. This is base exponent answer. We know that 9 squared is equal to 81. That is true, but I want to write it as a log problem. So log bacon and eggs would be log base 9 of 81 equals 2. Remember what I said, the answer to a log problem is the exponent if we were to write it in exponential form. Okay, so base exponent answer, because we're in exponential form, and I want to write it as log bacon and eggs. So it's log base 20 of 0.05 equals -1. All right. The next one, we're in base exponent answer form. I want to be in log bacon and eggs form. So it would be log base 16 of 8 equals 3/4. Okay, and the base, I'm sure you've noticed at this point, but the base is written in subnotation, small, smaller subnotation. All right, and this last one, I have my base, I have my exponent, and I have my answer, but I want to be in log bacon and eggs form. So it's log base 15 of 1 over 225, and you can put that in parentheses if you want, although it's not necessary, equals -2. Okay. And if you want to double check any of these just to show you how to put it in the calculator, which I am going to show you again later, but let me just check this one in the calculator so I can at least show you where to go for the calculator part. All right. So I'm going to pull up my calculator. Okay, so log base 20, if you notice on your calculator, you do have a log button, but that log button doesn't allow you to put in different bases. And we're going to talk about that in a minute. This is a log base 10. Okay, this button there only lets you do base 10. So if I need a different log, I'm going to hit math and I'm going to scroll down to log base. And that's going to let you put in whatever base value you need. So log base 20. And then can't really see what I'm supposed to be doing. Hold on 1 second. 0.05, 0.05. And I should get -1 as the answer when I push enter. And I do get -1. So you could double check that you set them up correctly if you want to use your calculator to do so. Okay. All right. Okay, so now we're going to evaluate. Now, I did just show you how to do these problems on a calculator, but I also need to show you how to write them out because as the problems get more challenging, we're not always going to be able to do everything on the calculator, okay? So what you're going to do here, all right, remember that the output, the answer, right, the output is the exponent when written in exponential form. So right now, I'm already kind of converting this in my head. I'm thinking to myself, the answer to this is the exponent in exponential form. So what I'm going to do is I'm going to change the form, okay? So you can set it equal to a variable. So if I want to set it equal to the variable x like this, and then I'm going to change forms. So change form. Whenever you hear me say change form, if you're in log form, you want to go to expo form. So knowing the different forms is important. Log is log, bacon, and eggs, but I want to go to expo form, which is base raised to an exponent equals an answer. Okay? So just like we were doing in the last problems, here's my B, bacon, and eggs. And I want to be in B raised to the E equals A form because I want to go into expo form. So it's 4 raised to the X equals 64. All right. So once you change forms, then what you're going to do, I guess I want to erase that, is if you can, you want to try to get the same base. Okay. So you look at the larger number and you ask yourself, can I rewrite 64 in terms of a 4? Or could I write both as like 2 to the something? So what I mean by that is 4 to the x, that's not going to change. But can you rewrite 64 as 4 to the something? It's 4 to the third. Okay, 4 times 4 times 4 equals 64. And then once the bases are the same, you can set the exponents equal to each other. Because 4 to the x has to equal 4 to the third if I have both sides of the equation, right? If I have them set equal to each other. So that means that x has to equal 3. Okay. Now, before you circle x equals 3 as your answer is simply a 3. All right. Don't include x. Do not include x or whatever variable you chose as part of your answer. The reason we don't include x as part of your answer is because x was not part of the original problem. We made it up. We put an x into the problem so that we could change forms. Okay, so don't include it as part of your answer because it's not part of the original problem. All right, so the answer is simply a 3. Okay. All right, so for the next problem, number 2, let me scroll down. So the first step for these problems is change forms. So I want to go from log form to expo form. Okay, and hopefully we're going to get faster and faster at doing this. Set it equal to a variable, and then it's b raised to the e equals a. Then you want to try to get the same base on both sides. Now, it might be helpful for this problem. Instead of 0.5, let's write that as 1/2. Now, this is a base 2. Well, couldn't I, on the right-hand side, isn't 1/2 the same thing as 2 to the negative first? Think about that for a second. If I said simplify 2 to the negative first, if I don't want negative exponents, wouldn't I rewrite that as 1 over 2 to the first, which is 1/2? So 1/2 is the same thing as 2 to the negative first. And now I have the same base. So after changing forms, again, what I'm trying to do is get the same base. You have to kind of manipulate one side, sometimes both sides of the equation to get the same base. And then once you have the same base, you set x equal to -1, and your answer is -1. Don't include x as part of your answer. All right, let's try another one. Okay, so for number 3, I want to go from log form to expo form. Set it equal to a variable so that you can change forms. So it's going to be 1/3 raised to the x equals 27. Okay, well, 3 and 27. I'm thinking to myself first, let's bring the 3 up. So it's going to be 3 to negative 1x, right? Bringing the 3 up is going to have a negative exponent. And then 27, can't I rewrite 27 as 3 to the third? Right? 3 to the third equals 27. Now that I have the same base, I can set the exponents equal to each other, solve for x. So x equals negative 3, but don't include x as part of your answer. So your final answer is just a negative 3. All right, let's try number 4. So set it equal to a variable and then change forms. I'm going from log form to expo form. If you still need to label, that's fine. It's bacon and eggs, but I want to be in base raised to an exponent equals an answer form. So I want to be in 64 raised to the x equals 8. All right, can I get the same base? Well, 8 squared is 64, so maybe I rewrite this as 8 to 2x equals 8. Now that I have the same base, I set the exponents equal to each other. The exponent on 8 is a 1, right? So now I can say that 2x is equal to 1. I'm going to divide both sides by 2 to solve for x. I get x is equal to 1/2. Remember, the x was something that we introduced into the problem just so we could change forms. So my answer is simply 1/2. Okay. All right. Let me see what else we're going to discuss today. All right. What's true about log base b of b and log base b of 1? Well, for log base b of b, we could come up with an example if you wanted, something like log base 5 of 5, right? Well, let's change forms like we've been doing. So set it equal to a variable. So if I change forms, it would be 5 to the x equals 5. Okay, if I set exponents equal to each other, x equals 1, I'm going to get 1. So will that work for all examples? What about log base 8 of 8? Well, if I set it equal to a variable such as y, I have 8 to the y equals 8. I'd set exponents equal to each other, and I get 1 again. So what I'm just discovering is that when the base of the log problem, let me erase this. When the base of the log problem is the same as what you're logging, when those two values are the same, this is always going to simplify down to a 1. Okay? And I can change forms even just using the variables. So if I rewrite it as log base b of b equals x, it would be b to the x equals b, x equals 1. So again, as I was saying, it's always going to evaluate down to a 1. All right. What about log base b of 1? Well, let's come up with a few examples again. What about log base 5 of 1? Or log base 8 of 1? So if I change form, set it equal to x, I'll set this one equal to y. I have 5 to the x equals 1. Here I have 8 to the y equals 1. Well, what does the exponent have to be so that it evaluates to 1? It would have to be a 0. X would have to equal 0. Y in this case would have to equal 0. So when you have log base b of 1, that's always going to evaluate down to 0. And I can change forms again. So base b x equals 1. I'm going to have x is equal to 0. It's going to evaluate to 0. Okay, and if you forget that, come up with some examples like I just did as well. All right, here it says evaluate using a calculator, round to the nearest thousands. So I showed you on the calculator, but let me show you again for these two. So for the first one, log 21, the base there it's called the common, it's called the common base. Common base. So if there is no base number written, it's common base, and the common base is base 10. So I could rewrite that as log base 10 of 21. That's the same thing as log 21. So again, if there's no base written, it's automatically a 10, and it's what is known as the common log. Okay. So on my calculator, I'm going to show you two places to do this. So I was saying that on your calculator, this log button, there is no option to put a base value. It's the common log. It's automatically base 10. So I can just type in a 21, close my parenthesis, push enter. All right. Or if I want to hit math and go down to, and then I can put in my base value of 10, and I should get the same answer, which I do. All right, so log of 21 or log base of 21 is approximately 1.3. It says around to nearest thousand, so 1.322. Okay, so I'll write that down. This is approximately 1.322. Okay, next we have ln, which we're going to talk about in, I think, the next lesson, if not the one after that. This is known as, oh, I can't write down there. I'm going to have to write right above the problem because I can't write that low on my screen. Okay, so I'm going to write above this one. It's considered the natural log. All right, so ln is natural log, and that always has a base e. Okay, so I can rewrite this actually a few different ways. ln of 0.54, that's the same thing as ln base e, but we just don't write it that way. You don't see the base e written there, which is actually still the same as log base e of 0.54. Okay, now there is an ln on the front of your calculator, natural log button here. So I can just type in ln and then 0.54 and get my evaluation. Or I can hit math, go down, select log base, put in a base of e, and then put in 0.54, and you'll get the same evaluation, approximately negative 0.616. All right, so I have approximately negative 0.616. Okay. All right, so that is it for lesson 6.3, day 1. I'll see you back here for day 2. Bye.